Hi, so let's solve this one. It says total pressure calculation, and it says given the molar mass of two molecules M1 and M2, their masses present M1 and M2 in a vessel of volume V at a specific temperature T. Find the total pressure P total exerted by the molecules. Formula to calculate the pressure is P total is equals to, then we have this small m1 over the big one. That's the big one saying the mass of the molecule 1, and this is the present mass plus the present mass of molecule 2 and the mass of the molecule 2 itself. Then R, which is going to be a constant, we're going to see the value, and T, which is specified here as a specific temperature, and V, which is the volume. So input, it says 6 values, M1, M2. It says molar masses of both gases in grams. Then the smaller M1 and M2 present mass of both gases in grams per mole. And this is volume, V for volume of the vessel in dm cube, and T is temperature in degrees Celsius. So output, it said value P total in units of ATM. Notes, it said remember temperature is given in Celsius, while SI unit is Kelvin. So 0 degrees Celsius is 273.15 degrees Kelvin. And it says the gas constant R is 0.082 dm cube and ATM per Kelvin and per mole. So let's consider that in this formula, this R is going to be represented by this value 0.082, and the temperature, we are going to have it converted into Kelvin because currently it's in Celsius. So that's the first thing we are going to do. So let's come to JavaScript here to solve that. And since we have already been given the variable temperature, we are just going to change that here, and we'll say temperature is the current temperature plus, now we want to add this value here in Kelvin to change it to Kelvin. So this is the new temperature in Kelvin, is what is passed to temperature. So now we are meant to now represent this formula. So to do that, we will then return, and what we want to return first is what will be inside this bracket here, then multiplied by the R, which is going to be this constant we have here, right? Then multiplied by the T, temperature, which is this temp, which we've converted to Kelvin, right? So, and finally divided by the V, which is the volume. So that volume is this. So now let's put in the values in here. So we have M1, the smaller M1 is the given mass 1. We'll put that there. Then divided by the molar mass of 1. Then we have added to M2, that is the given mass M2, divided by the molar mass M2, that way. And I think this should solve the formula. So let's test, and that passed, attempt, and that has passed. So that's the way to solve this. And let's see if we can just refactor this by putting this value inside here. So we'll put it that way, and then we can take this off. So now we have this. So let's test and let's attempt. So good. So that's the way to solve this in JavaScript. So let's go to Python. And Python, we have the same thing. So we'll do the same thing. Basically, we'll take temp and we are going to add the temperature to that in Kelvin. Change it to Kelvin, convert it to Kelvin, and when we've done that, we can now return. So we're going to return those in the brackets, then multiplied by the constant of R, as this, then multiplied by, we're going to now take this on temperature, and then divided by, now we're now going to divide by the volume, and then let's put in the values. So given mass 1, this divided by molar mass 1 plus given mass 2 divided by molar mass 2. So that seems like we are done. So let's test, and that passed attempt, and that passed. So we can now refactor this by just passing this in here that way. And let's test again. That's good. And attempt. That's good. So that's the way to solve the total pressure calculation. If you have any questions.